Hi. In the previous lecture, we have started with the reactions of the carbohydrate, especially the reaction of the monosaccharide unit. And we have discussed several kind of the reactions, including the most important one is that oxidation and the reduction type of the reaction. So, oxidation type of the reaction that can happen in under the mild condition as well as under the strong condition. And under the mild condition, normally bromine water that is used, thus forming converting the monosaccharide unit into the corresponding aldonic acid. Onic, you can see onic acid. The ending is onic acid. This is the nomenclature. Aldonic mean that is an aldehyde substance. Onic mean uh, it's a oxidation process. So in the as a result of the oxidation process, there is the formation of the acid, as I told you earlier in the previous last lecture. And in case of the reduction process, the end product is alcohol, just like the sorbitol, right? So among the oxidation reaction, there are different condition and different product that can be formed. So under the mild condition, especially, normally the aldonic acid is formed. So look at this example. You know, now know the all the structures of the five carbon, five carbon and six carbon type of the monosaccharide unit. You have already practiced all that monosaccharide unit. So what will be your home task now? To draw the structures of all the five carbon aldo sugars, and try to work on that for the oxidation reaction, what kind of the product that is actually generated. So look at this one. For example, this is a ribose. It's a 5 carbon aldo sugar. So this aldehyde group that is converted into this aldehyde group that is converted into carboxylic acid group. This was the C double bond OH, that is after the oxidation process, COOH, carboxylic acid is formed. The remaining part that is the same. The remaining part that is the same. So this ribose that is converting into the ribonic acid. If you have the glucose, that will be converted into the gluconic acid. The aldehyde part that is converted into COOH part. So this is the onic acid. Ribose, from ribose, ribonic acid, from glucose, gluconic acid, from allose, allonic acid. Only this first aromatic carbon that is changed into the carboxylic acid. Another condition, this happened under the mild condition. You can see pH is about 8 and the bromine water that is being used. Under the harsh conditions, mean the use of the strong acid, HNO3 is a strong acid, right? So what happens, there is two change. In the first part, when the condition is mild, only this aldo group that is converted into COOH, carboxylic acid group. Under this condition, this is the strong condition, the first carbon and the last carbon that is actually converted into COOH, carboxylic acid. You can see here. You can see here. Either it's a 5 carbon compound or it's a 6 carbon compound aldo sugar. The both terminals that is converted into COOH, carboxylic acid. So you will try again all of that. And what are the product? That is the aric acid. This is ending aric acid, from ribose, ribaric acid, from glucose, glucaric acid, from mannose, if this is the mannose, mannoric acid. Aric acid is the ending. You should remember aric acid is the uh, ending. Here onic acid is the ending. So you can see here from the arabinose, arabineric acid, from the laxose, laxaric acid. So you will try with all the monosaccharide units that I have already told you. So you will try today with all the 5 carbon and 6 carbon aldo sugar monosaccharides, how that are converted on the oxidation process. So another reaction, that is the reduction process, that was the uh, process of oxidation. Now we will be talking about the reduction process. So reduction process that take under the separate condition, normally that require the sodium borohydrate as a reducing agent. So under the presence of the sodium borohydrate, several reduction reaction that can happen, and the common nomenclature, we call them as the alditol formation. Alditol formation. If you are having the ribose, working with the ribose after the reduction process, that is converting into uh, uh, ribitol, ribitol after the reduction process, ribitol. So all of these reduction processes that happens in the presence of sodium borohydrate. So allose that is converting into the xylitol, galactose that is converting into galactitol, and this is the reaction in the presence of NABH for reduction. And how that happens, the CHO part, the first aromatic carbon, when C two hydrogen atom that is being added, that is CHO part that is converting into CH2OH, CH2OH. The remaining chain, that is the same. So again you will try that. Then there are some short chain shortening and chain lengthening type of the reaction. Uh, the chain shortening reaction, that is called as the rough degradation, RUFF, rough degradation, and chain elongation reaction, that is called as Killiani-Fisher synthesis reactions. So look at this one. Uh, th this is 5 carbon compound or 6 carbon compounds. So if there is uh, uh, some reaction that will be happening in the presence of ferric and calcium carbonate, that result in one carbon shorter than the reaction start. Here, this is a 4 carbon compound. Let's say it's a 4 carbon compound or 5 carbon compound or the 6 carbon compound. If it's a 4 carbon compound, that will be converted into 3 carbon compound. You can see here, if it's a 5 carbon compound, that can be converted into 4 carbon compound. If it's 6 carbon compound, that can be converted into 5 carbon compound. So this is a rough degradation. One carbon that is being going to less Cn minus 1 aldose that is found. And in the chain elongation process, uh, uh, normally that is called as the Killiani-Fisher synthesis process. So either the lactonization process or the reduction process that can going to happen. So look at this one. Among this process, there is an increase in chain length. So it's a 4 carbon compound. So after the addition of 1 carbon, that is the again happening with the lactonization oxidation process. This is a strong oxidizing agent is seen. in the presence of the H3O that is increasing the chain length. You can see the details of that and try to practice at home all of that reactions. This we have discussed already discussed. So this is the example. This is the example how the glucose that this is the example for the reduction process. This is a glucose molecule. So look at that where this glucose molecule after the reduction, sodium borohydrate will be used in this process of reduction. This CHO that is converting into CH2OH. This H2 that has been added into the during that reaction, right? Same is the case with the fructose. This is a keto sugar that can also undergoes the hydrogen process, reduction process. So in this case, what is the reduction process? Addition of the hydrogen basically. So look at this one. Here we have added the hydrogen at that point. And here, in the case of the fructose or in case of the keto group, the hydrogen is added at the second number carbon. One hydrogen is added on this side, one hydrogen is added on this side. So forming this fructose that is either converted into the glucitol or in the mannitol. But in case of the glucose, it's a haldo sugar, only the glucitol or the sorbitol that is possible. But in case of the fructose molecule, because the hydrogen is added at this point, second carbon, so there is either the possibility the formation of the glucitol or the mannitol. So you will read all the description here. So this is a detail of another oxidation process, that is the aldonic acid, dicarboxylic acid, and the uronic acid. And for aldonic acid, we have seen the reaction that is the first carbon that is oxidized actually into carboxylic acid. In case of the dicarboxylic acid, that reaction takes place in the presence of the strong oxidizing agents such as HNO3, and we have seen that the first carbon and the last carbon that has been oxidized into the COOH carboxylic acid group. In case of the uronic acid, actually only the last terminal carbon that is going to oxidize into the carboxylic acid COOH. So during that oxidation processes, either it's a top first carbon, first and the last carbon, and last carbon only. So there is some of the intermediate product. The most important one is the formation of the delta lactone. So when this reaction oxidation happens, the intermediate product that is also developed, that is called as the delta lactone. So look at this one. These are the delta lactone. For example, we have started with the glucose, and after the oxidation, we know that the gluconic acid is formed. What is the gluconic acid? Onic means only the first carbon that has been oxidized into COOH. So these are the actually intermediate product. These are the intermediate product, either the sigma lactone, either the gamma lactone, glucono-gamma lactone. So this is the lactone. Lactone means there is an oxygen addition. At the first carbon, there is an oxygen addition. So this oxygen addition later on that is converting into the carboxylic acid. So look at this one. It's a pyranose ring form. And when we talked about the gamma lactone, it's a furanose ring form. Furanose ring form. And the first carbon is at double bond O. You can see first carbon, double bond O. So this sigma electron at the first carbon, double bond O, it's a pyranose ring and it's a furanose ring, and ultimately the final product is a gluconic acid, mannonic acid, alonic acid, the first carbon that has been oxidized into the COOH form. So you can see all with this. This is the galactose, how that is converting, and this is the uronic acid. Uronic acid means the last carbon is oxidized into COOH, or the carboxylic acid. Aldehydic acid means the both first and the last carbon that has been oxidized. So you will try all the 6 carbon, especially monosaccharide, with these uh, reactions. And you will read all of this commentary, that is the strong acid media, strong acidic, just like the HNO3, HOBr is the mild condition. So you will see all what is happening under the mild condition and the harsh condition. And during the caramelization process, there is the formation of some of the furfural. Again, it's an aldehyde substance. You can see CHO. It's an aldehyde type of the substance, and you can see the ending of that. That is an ending of AL aldehyde. This has an ending of the AL aldehyde, and you can see C double bond OH. This is an aldehyde type of the substance. So, furfural, it's a journal furfural, and this is a 5 hydroxy at the fifth position. Uh, first carbon, second carbon, third carbon, fourth carbon, and this is the fifth carbon. First carbon, this is the first carbon, second carbon, third carbon, fourth carbon, this is the fifth carbon. So at the fifth carbon, CH2OH, 5 hydroxy methyl. This is the hydroxymethyl that is positioned at the fifth number carbon. So that is called 5 hydroxymethyl furfural, and that is the substances that are developed during the heating process, caramelization of the sugars, as well as the Maillard reaction, as well as the Stryker degradation type of the reactions that we have covered in the last lecture. So the step in the formation of 5-hydroxymethyl furfural, any diol reaction that are actually involved, and we have seen in the previous lecture the formation of the anidiol reaction. So once again I am repeating that. For example, we are starting with the glucose. There is a transfer of, you can see the hydrogen from the second carbon to the first carbon. So there is a formation of 1,2-anidiol. So when the hydrogen is removed from this one, that is automatically converted into the fructose. So what is the consequence of that? The aldo sugar that is converting into the keto sugar through the anidiol reaction. When the aldo sugar have to convert into the keto sugar, that have to go undergo with the anidiol type of the reaction, and the intermediate product that is formed, that is the 1,2-anidiol. And against to that, opposite to that, when the keto sugar have to convert into aldo sugar, this is the aldo sugar. After that is the aldo sugar that has again undergoes the anidiol reaction. But what is this kind of the reaction? This is the 2,3-anidiol reaction. This was the 1,2-anidiol reaction, and this is the 2,3-anidiol reaction. And you can see here carbon number 2 and carbon number 3 is involved here. Carbon number 2 and the carbon number 3 is involved here. You can see this hydrogen that is again going to that point. We have discussed about that, how that happening. Look at this one. In the D-glucose molecule, only the first 3 carbon that have been shown, the 3 carbon later that is omitted. First of all, 1,2-anidiol reaction, and this caused the formation of the mannose. So mannose that can be formed from the aldo sugar, mannose that is formed from the keto sugar as well. fructose, you know, that is the keto sugar that will undergo 2,3-enediol reaction to form the cyclose, or that can undergo 1,2-enediol reaction to form the again the aldo. Mannose is an aldo sugar. So if there is formation of the aldo sugar, there is the that have to undergo 1,2-enediol reaction. If that have to go for the keto sugar, that have to pass for 2,3-enediol type of the reaction. Only first three carbon that has been shown. The first three carbon that have been shown in this reaction, you will write all the 6 carbon. So look at this one again. This is more clear how that is happening. Only the 3 carbon that have been shown here. The later 3 carbon that is omitted due to the space. So again, you will practice all of that again that I have written here for the practice purposes. You will doing the practices for all and try to understand the aldonic acid, difference between the aldonic acid, uronic acid, ending uronic acid, and alderic acid. Alderic acid mean first and the last carbon that has been oxidized. Eric mean the first and the last carbon that has been oxidized. So that's all for today. You will read all of these things, striker degradation, we have covered in the last lecture. So these are you may consider your notes. Striker degradation reactions, Browning type of the reaction, melanidin formation reaction, Maillard reactions, caramelization reactions, striker degradation reactions, esters formation. So all of this for the next time we will be starting uh, with the polysaccharides molecules. For so we will be closing our lecture at this point. Hope to see you in the next lecture, inshallah.